All right, hey guys, welcome back. So this should help us get a better understanding and make sure we're on the same page about the lac operon stuff. So let's go and take a look at this first situation here. Remember, we talked about this in the last video that glucose will tell us about CRP and the promoter, and the lactose will tell us about the repressor. And both of those are important in deciding whether the lac operon is on or off. So let's talk about the plus glucose first. If we have lots of glucose, if we have high glucose, what does that mean about CAMP? If we have high glucose, hopefully you're thinking, oh yeah, I know that means we have low CAMP or CAMP. If there's low CAMP, what does that mean about CRP, the promoter? Right, CAMP is what activates the CRP. So if there's no CAMP, this means that CRP can't bind. So we're not going to draw any CRP over here. Let's go ahead and look at the plus lactose part. Lactose, what does it do to the repressor? Does it activate the repressor or does it inactivate the repressor? This is what inactivates the repressor. So lactose turns the repressor off. Does that mean the repressor is bound here or not bound here? Yeah, that means that the repressor would not be bound. So in this example, we don't need to draw anything on here because the CRP is not bound and the repressor is not bound. Remember, in order for the lac operon to be on, you need two things. To be on, you need two things. Number one, you need to make sure that the repressor is not bound, right? Or else it would be repressing everything. And the second thing is you need CRP, the promoter, to be bound. Right, CRP is kind of like waving a little hand at RNA polymerase saying like, hey, come down here and bind. So in this case, even though the repressor is not bound, CRP isn't bound either, and that's what we need. So you would say technically that this is off. The lac operon would be off in the situation where you have glucose and you have lactose. Or sometimes you might see on at low levels. The only reason that this is true is because there's no repressor blocking everything. So technically small amounts, technically like every now and then RNA polymerase like could bind, like by chance land on here and transcribe the genes, but the chance of RNA polymerase doing that without their promoter bound are very, very low. So both of these are acceptable answers, on at low levels or off. Okay, next we can talk about part B, where we do have glucose, and it's the same deal as last time, right? If we do have glucose, that means we don't have CAMP, which means CRP cannot do its job. So I'm just going to skip to the part where CRP can't bind. Then if we don't have lactose, what does that mean about the repressor? If we don't have lactose, that means that the repressor is active, which means that the repressor is bound. So we can go and draw the repressor on here. Just shout out to all you visual learners out there. This is our repressor. This is a big R for repressor. So in this case where we do have glucose, there's no CRP to be seen, but there is a repressor there. So in that case, the lac operon is definitely off, right? The repressor is there blocking everything. So this would be off. I guess no need for quotes. It's true, it's off. No quotes about it. Cool. Then the next one, if there's no glucose, low glucose, what does that mean about CRP, or sorry, CAMP, sorry. Low glucose means that we have lots of CAMP, CAMP. What can CAMP do? Just activate CRP, which means CRP is bound. So that's great. So we can go ahead and draw CRP here. CRP. The main point here is that when you don't have glucose, this chain of events will happen and CRP will be bound, and it'll be like waving its little hand to call over RNA polymerase. So we can do transcription. Just sort of think about the lactose, just like the one before. If we don't have lactose, the repressor is active, which means that the repressor is bound. So the repressor would be right here. Right, so this is a situation where, okay, yeah, maybe we do have CRP calling over RNA polymerase, but it doesn't matter because the repressors are blocking everything anyways. So in this situation, the lac operon would still be off. Glad that hint. Cool. All right, last but not least, I'm sure that these are all three off. You can like see where this is going. But go and pause the video now and see if you can like logic yourself into it. Why would it be on here? Anyways, we have low glucose, which means we have high CAMP, which means that we have active CRP, which means that CRP will be bound. Right, so CRP will be bound to the promoter. Sorry, not CPR, CRP. Don't get those too confused. And then we do have lactose. So what does lactose do to the repressor? Lactose inactivates the repressor, which means that the repressor is not bound. So no need to draw a repressor here. It's not there because it's being inhibited by lactose. So now we're in a situation where we do have the repressor, it's not bound. So that's the win, it's not repressing. And we have CRP bound, it is promoting. In this situation, we have CRP here and no repressor there. This is when RNA polymerase would be able to bind and transcription would be able to happen. And that's why this would be lac operon being on.